Have you ever woken up early on a cold morning, looked at your window, and noticed something strange? Delicate, feathery patterns spreading across the glass like tiny frozen forests? They look almost too perfect to be random, like nature suddenly decided to become an artist overnight. But here's the real mystery. Frost doesn't just freeze, it designs. So why does frost form these intricate patterns instead of just a flat sheet of ice? Let's explore right here on History of Simple Things. To understand this, we need to start with something simple: how frost actually forms. Frost appears when water vapor in the air turns directly into ice without becoming liquid first, a process called deposition. This happens when the temperature of a surface, like your window, drops below freezing. Instead of forming droplets, the water vapor skips the liquid stage entirely and crystallizes into solid ice. But here's where it gets interesting. This process doesn't happen evenly. If frost simply froze uniformly, your window would look like a plain icy blur, but instead it grows in branching tree-like structures. Why? Because frost formation is deeply influenced by the invisible world of molecules, temperature differences, and even tiny imperfections on surfaces. At the microscopic level, ice crystals always begin with a specific shape. Water molecules arrange themselves into a hexagonal structure when they freeze. That means every tiny frost crystal starts as a six-sided pattern. But as more water vapor joins the crystal, it doesn't just pile on evenly. Instead, it tends to attach more easily to certain points, especially edges and tips. This creates a fascinating effect. The edges of a growing crystal attract more molecules than flat surfaces do. So instead of growing outward smoothly, the crystal begins to branch. Each branch grows new branches, and those grow even smaller ones. This is how you get those fern-like, feathery frost patterns that seem almost alive. But that's only part of the story. Temperature plays a huge role in shaping frost. Slight differences, sometimes just a fraction of a degree, can change how fast different parts of the crystal grow. If one area of the surface is slightly colder, frost will grow faster there. If another area is slightly warmer, growth slows down. These tiny variations create uneven growth, which leads to complex and beautiful designs. Humidity also matters. The amount of water vapor in the air determines how much building material is available for frost. When humidity is high, crystals can grow quickly and form larger, more elaborate patterns. When it's low, frost might appear thinner or more sparse. Now let's talk about something you might not expect: your window itself. Frost patterns are heavily influenced by the surface they grow on. Even though glass looks smooth, it's actually full of microscopic scratches, dust particles, and imperfections. These tiny flaws act as starting points, what scientists call nucleation sites, where ice crystals begin to form. Once a crystal starts growing from one of these spots, it spreads outward, competing with neighboring crystals for space and water vapor. This competition creates boundaries, shapes, and patterns that look almost like territories on a map. That's why frost can sometimes form distinct patches or symmetrical designs across a surface. Air movement is another hidden factor. Even a slight breeze can affect how frost grows. Moving air can bring in fresh water vapor or remove it from certain areas, changing how crystals develop. This adds another layer of randomness to the process, making every frost pattern unique. So what you're really seeing when you look at frost isn't just frozen water, it's the result of a complex interaction between physics, chemistry, and environmental conditions. It's a natural example of something called diffusion-limited aggregation, where particles cluster together in branching patterns because of how they move and attach. This same principle shows up in things like snowflakes, mineral deposits, and even some biological growth patterns. Speaking of snowflakes, frost patterns and snowflakes are actually closely related. Both form from water vapor turning into ice, and both grow based on hexagonal structures. But while snowflakes form in clouds and fall through changing conditions, frost grows directly on surfaces, influenced by everything from temperature gradients to the texture of the material beneath it. This is why frost can sometimes look like tiny forests, feathers, or even abstract art. Your brain tries to recognize patterns, and because frost grows in branching organic shapes, it often resembles things we're familiar with in nature, like leaves or ferns. But here's the most fascinating part. No two frost patterns are ever exactly the same. Even the smallest change in temperature, humidity, or surface condition can lead to a completely different design. It's like nature is running an endless experiment, creating new artwork every single time conditions are just right. And yet, despite all this randomness, there's still an underlying order. The hexagonal structure of ice, the tendency for edges to grow faster, and the physics of molecular movement all follow consistent rules. Frost patterns are a perfect blend of chaos and structure, unpredictable in appearance but governed by precise scientific principles. So the next time you see frost creeping across your window, take a closer look. Those delicate patterns aren't just decoration, they're a frozen record of invisible forces at work. Temperature shifts, air currents, molecular attraction, and surface imperfections all come together in a fleeting moment to create something incredibly detailed and unique. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.